I've done already.
And you will post
Yeah.
on YouTube later.
Yep. All right. Hi, everybody. I hope you can hear me. Let me go ahead and start recording. Let me go ahead and start recording. So welcome, everybody. This is the virtual meetup for July. And it's my pleasure to have with me today Alexei Milovidov, as well as Alexander Zaitsev, and also as a special bonus, Ivan Blinkov. Both Ivan and Alexei work for Yandex, and thanks to this time are able to attend. What I'd like to suggest is I'm going to go ahead and enable everybody to talk. If you would like to go ahead and just introduce yourself, we could sort of go around the room, see who's attending and where you all come from. So if we go in alphabetical order, I'm going to go ahead and, Artyom, I've just allowed you to talk if you want to go ahead and introduce yourself. Okay, actually, I've unmuted a number of people. If for those of you who would like to introduce yourself, anybody like Mallikarjuna, if you don't mind, if you want to introduce yourself, tell us who you are and where you come from.
So my name is Malik. I was working for Netscope, and recently I'm joining a different company. I was interested in ClickHouse and basically looking at performance-wise how for some use cases.
Excellent. Welcome to the meetup today. Next one is an old friend, Pauline Young.
Thank you.
Hi, this is Pauline Young. I work for Cisco umbrella team. I've used ClickHouse in my previous team at Cisco, and I'm looking at using ClickHouse in another project in this new team.
Awesome. Okay. Next one is Shishir Jain. I hope I didn't mess up your name too much.
No, sure. Yeah, thanks. The Shishir, actually, I work at Walmart Labs. So we are using actually ClickHouse actively in our platform. So we are looking forward to hearing from the experts here.
Excellent. Okay. Let's see. I've just unmuted Hugo Gonzalez. If you'd like to introduce yourself.
Hi, I'm Hugo. I just started working at Nuna, so yeah.
Joining the fun. Artyom, if you are able to speak, you're unmuted.
Yeah, let's try this time. Hi, my name is Artem Germanov. I'm an engineering manager at Postmates, and at Postmates we are actively using ClickHouse as well. So wondering what other guys are using ClickHouse for.
Great. Okay. Let's see. Mohammed Hilia. Oh, wait a second. Let me.
Hello, everybody. I'm Mohammed Hilia from Epon Technologies. I'm a data architect, and we recommend ClickHouse as the BI tools in our data architecture consulting missions.
Great. Okay. Let's see. Trying to Nitin Sharma. You should be unmuted.
Hi, can you hear me?
Yes.
Yes, so my name is Nitin. Actually, I work for Indian e-commerce company, Flipkart, and we are using ClickHouse in our production clusters. And I would like to thank Altinity webinars. They have really helped me increase the gap in my knowledge. And because of that, I was able to work on the POC and take it to the production. And looking forward to this meetup.
Excellent. Thank you. And I hope you're not staying up too late for this. Let's see. Next one is Moksh Jawa. I don't know if I can unmute you. That doesn't seem like.
Yeah.
Awesome.
There we go. Yeah, I also work with Hugo at Nuna. Just started working with ClickHouse like a month ago, and I've enjoyed it. So looking forward to hearing about more of the updates.
Okay, great. Let's see, Stefan Pham. Let me can't tell if I'm having some trouble unmuting you. Okay, you may not have audio enabled. Alexei Pekin, if that's correct.
Hello, we are using ClickHouse in production. For several years, I'm trying to learn more about new features and see how we could use it in most scenarios.
Great. Alexei, where do you work?
I work for a company called Workato.
Okay, great. Welcome. Good. Let's see. I'm just trying to, let's see. There's a person who's dialed in 1408-463. I'm going to go ahead and allow you to talk if you want to just introduce yourself. Okay, don't hear that person. So let's see. Amay Desai.
Hi, this is Amay. I also work at Nura, and we have been productionizing ClickHouse to power our analytics app and also using it for other purposes. So quite excited about actually using ClickHouse and hopefully to contribute back to it also in the future.
Awesome. Next person, I just enabled Brad Johnson. If you want to, it doesn't look like you're enabled. Let me try to unmute one more time. Okay, it doesn't look like Brad. I'm sorry, I tried to unmute you, but I can't. Leandro Gutierrez. If you want to introduce yourself.
I didn't know what kind of meetup this was. I thought it was just a little, I didn't know I'd be introducing myself. I thought I'd just tune in and what's going on.
So this is a community, just to be clear, this is the ClickHouse community in San Francisco. And yeah, so it's kind of, normally we'd be meeting down at some place like Cloudflare and maybe having a beer and a bunch of pizza and then doing talks. So we're trying to recreate a little bit of this on Zoom.
Okay, yeah, I'm actually in Colorado.
Oh, welcome. Welcome. That's awesome. We saved you a plane flight.
Yeah.
Good. So maybe, are you using ClickHouse now, or maybe you could just briefly describe your experience with it?
Yeah, I don't think I can say how I'm using ClickHouse right now, just because I'm not officially here with the company I work for. I didn't talk to them about doing this because I didn't know I'd be talking. But
no problem.
Yeah, I probably shouldn't say anything because I don't know how much I should say.
No problem. You can, anybody who feels comfortable, you may keep an air of mystery about you. Let's see, Courage Noko, if you want to just tell us who you are, if I can unmute you, that is. Let's see.
Courage Noko. I'm at Spotify. And
oh, welcome.
Thank you. And we are currently exploring ClickHouse. It's actually, we just pushed it to production. So,
great. All right, well, welcome. Nirav Quintar.
Hey, hi, this is Nirav. So I'm working in a Walmart Labs. And we are not using the ClickHouse, but I recently attended your talk at the CMU database talk. So I mean, like after that, I started following it, and I just this is my first. I'm attending first time, so I just wanted to see what's going on with the ClickHouse and what are the. I saw on the event subject that a couple of cool features that you guys are going to introduce. So yeah, that's why I wanted to attend.
Okay, great. Let's see. I've got Zuhair. I'm going to go ahead and allow you to talk if you want to introduce yourself.
Yeah, hi there. I'm Zuhair. I'm also new at Nuna. Been working with Ame, Moksh, and Hugo. Starting to use ClickHouse for the data analytics platform that we're building out here. So yeah, just excited to learn more, become part of the community.
Awesome. All right, I see Reifert Story. I'm going to try and unmute you. if you're able to unmute and you want to introduce yourself, go ahead.
Yes, Rayford Story. I'm also with Nuna. We're looking to use ClickHouse in production.
Oh, there's a lot of y'all. Excellent. Did I miss anybody? Because people are joining the list and it's a little bit tricky to keep. I think we got everybody. If I missed somebody, please go ahead and raise your hand. I can unmute. Otherwise, what I'd like to suggest is that we go ahead and get started. So our two guests today are Alexander Zaitsev of Altinity. He is the CTO and the founder of the company. And also a close friend and collaborator, we have Alexei Milovidov, who is the original designer of ClickHouse and is the lead committer. Two other people on this call that you may hear from, obviously me, I'm CEO of Altinity. I'm also an organizer of the SF ClickHouse meetup. I've been working with databases since 1983, so it's been a while. I won't be talking though too much today, other than once we get through the intros. And then finally we have Ivan Blinkhoff, and Ivan works for Yandex. If you've ever used the ClickHouse.tech website, a good chunk of that is Ivan's handiwork. So Ivan, we are greatly indebted to you for the work you've done, both on that as well as other community events. With this, I'd like to go ahead and turn it over to Alexander Zaitsev, who's going to walk through briefly some interesting things coming up in the roadmap. And then what we'll do after that is we're just going to open it up to questions. And this is like, you want to know something about ClickHouse, we're here to answer. And we have the foremost experts in the world on this subject, both the internals of ClickHouse itself, as well as how to apply it in the real world. And we're delighted to hear from you. We'll go until the questions run out. So with that, Alexander, go for it.
Thank you, Robert. Can you hear me okay?
Perfectly.
Okay, so thank you everybody for joining us today. As Robert introduced, we will start with the short presentation that will highlight some interesting ClickHouse features that we think, I think, are important for community to know. We have Alexei that will help me to describe some new features and optimizations of ClickHouse. And later on, we will go to roundtable mode when you can ask questions regarding some use cases, regarding some features, regarding some future, whatever, and we will try our best answering them. So let's start. It's me and Alexei Milovidov who will be mostly answering your questions. I'm CTO and co-founder of Altinity, and Alexei, he works in Yandex, and he is father of ClickHouse. Let's put it this way. ClickHouse is his child. There are two companies that you know us. It's Altinity. This is a company who tries to build enterprise services for ClickHouse. So we're actually building software services and many interesting stuff, popularizing ClickHouse mostly in United States and Western Europe. From the other side, Yandex is the company who developed ClickHouse originally by Alexei's hands. It's still a major user and contributor to ClickHouse source code, and also a sponsor of community in Eastern Europe and Asia. So we kind of split it the world a bit. So by the way, it is 1 month since ClickHouse has got his 4th birthday. So 4 years ago, ClickHouse has been released in open source, and since then, ClickHouse evolved quite a lot. When it first appeared, if anybody tried to use it in 2016, it was very cool technology, but it was very immature. So it lacked a lot of features. It was very fast on some very focused use cases, but if you step aside to some not so solid ground, you could get into troubles and problems. And since then, we are working with Yandex folks and with community together in order to build a better ClickHouse. And that includes certainly features. So a lot of features has been added in these 4 years. That includes performance, because performance is a cornerstone of ClickHouse. We always like to say that ClickHouse не тормозит. So ClickHouse doesn't slow down, if you want to translate it to English, or push us forward. And we try to preserve it and improve it. So every new feature, it's always tested for performance, and we have a lot of performance improvements across the board. We also invest a lot in usability, so make it ClickHouse easier to use, especially for newcomers. Certainly, if you're using ClickHouse for a couple of years, you already know a lot and how to avoid some pitfalls and whatever. But if you are new to ClickHouse, you kind of expect the database to be user-friendly. So ClickHouse is getting more and more user-friendly. And last but not least is ecosystem development. 4 years ago, there were no projects around ClickHouse at all. Now there is a bunch of systems and solutions that integrate with ClickHouse, starting from monitoring systems and some more advanced applications. And certainly there are a lot of applications that use ClickHouse inside, and you may use these systems even not knowing that there is a ClickHouse inside. What I would like to highlight today is 4 different things, but certainly we're not limited to discussing those 3 topics. First is S3 disk for tiered storage mainly. This is a feature that will eventually change ClickHouse and in the way that ClickHouse is used in clouds. So we will briefly talk about that, what we have right now, what is good, what is bad, and how it can be improved. Second is polymorphic merge tree parse. So merge tree, as you know, this is the key for ClickHouse performance, is a key technology, and it's getting some changes right now that includes different formats for parts. And I will introduce some of them and announce some that should come later this year, probably next month. Also, I will briefly enumerate some interesting improvements about clustering functionality, about replication and distributed tables. Some of them are already in ClickHouse, some of them are still planned for future releases. And next, we'll talk a bit about some performance optimizations. This is certainly my personal choice for highlights. You may have some other favorite topics, so we can discuss them later on the roundtable. Let's start with tiered storage. As you know, ClickHouse supports multiple storages right now, so it's possible to plug different disks and organize disks to volumes and organize volumes to policies that instruct ClickHouse how to move data around. And one of important use cases about that is how to implement tiered storage when you have your last day data in very fast but pretty expensive storage. And then you may have some other data that you don't access too often to go for some slower storage. And at the end, you don't need to delete everything. You may move it to the cold storage, which is typically some S3 compatible storage. Through last year and the half of this year, both ClickHouse team and Altinity team were focused in order to make this multi-disk and tiered storage to work. It's already production ready. It has some issues, but you can use it, and many companies are using it already. So the last piece that was missing, and we're now trying to fill it, is object store for very cold tier. And we already have it. So starting just not probably from 20.5, you can configure S3 already, but it's still very experimental. So I even put the next version number here as a version when it's going to be available, because there was some very important bug fixes in there. So when you define a disk, you can define a type, which is type S3 in this particular point, and there is a particular case, and there is a bunch of parameters that you can configure, mainly endpoint and access control rights. And once you have it, you can now use this S3 disk as a part of the volume configuration and as a part of your policy configuration. How to use volumes, policies, and disks, you can find in Altinity blog. We had 3 or 4 articles on this topic and also had a webinar earlier this year. So quite recently, this functionality started to be available in ClickHouse, and we started to test that. And this is interesting results of testing on-time data set. This is one of example data sets in ClickHouse and quite popular in different benchmarks. So I just took the data and put it in Amazon in 2 different disks. One is EBS, which is default choice in AWS, and another one is S3 configured in ClickHouse, and run several different queries from this benchmark. As you can see, it's quite slow. It's typically 3 to 10 times slower than EBS out of the box. Under the hood, how it works. So ClickHouse keeps storing references on local storage, but the data files itself are stored at S3. This structure allows ClickHouse to do file manipulations easily on local file systems because it only can manipulate with references, not keeping the data which is kept at S3. For example, if you need to rename a column or rename a table, this operation is very inconvenient in S3, but when you have only a reference to the data, you can do rename on your metadata and some local files, but your actual data, which is stored as S3, is unaffected. This is quite an interesting implementation thanks to Yandex Cloud folks that implemented that. But with S3, all file system operations are quite expensive because for every write or every read, you need to open up a connection or take it from the pool, make a HTTP request, and so on and so forth. This is much more expensive compared to local file system. And this is one of the reasons why performance is slower. In particular, inserts are terribly slow right now in the current implementation. And we'll talk a bit later on the way how it can be improved. Also, since operations are expensive, it makes sense to have the data merged, pre-merged before you move the data to S3 storage. So, and that will ensure that you have less reads on your remote storage. The read itself might be fast, but the initiation of the read is expensive. And that leads to another interesting observation that parallelization helps a lot. Actually, there are a bunch of tools for S3 that claim increased performance on uploads and downloads, and this increased performance is all because of parallelization. And here is the result of another experiment. Originally, this benchmark was running on pretty mediocre Amazon web server, Amazon EC2 instance with 2 threads. Actually, it was four CPU cores, but only 2 threads is used by default. But if we bump the query to 8 threads, the results are very different. As you can see, performance of S3 storage for select for query is almost the same as performance of EBS, which is block storage on AWS. It's certainly slower, and if I would add max threads 8 to EBS queries, that would be a bit faster as well, but it's already comparable. For cold storage that we expect to keep the data which is not requested very often, this is already good performance. Certainly, we still have to optimize a bit, but this is something that we can already demonstrate. Let's put it this way. Next topic is polymorphic merge parts. And polymorphic means that there are different ways to organize the data right now. Originally, parts in merge tree are called wide, when every part, which is a data folder inside the ClickHouse data directory, and I will show you in a minute how it looks like. It contains a bunch of different files, including index file, and for every column, ClickHouse stores at least 2 files. One file with the data itself, and another file with marks. Marks which are references to granulars inside the column binary file. So if you have 10 columns, for example, it will result in at least 20 files for columns, plus index, plus few files with some additional data. That works fine on a block device, but not very good if operations are expensive, and not very good when you need to write frequently. So every insert has some fixed cost, because you need to write many files, and this fixed cost can be reduced. That's the reason why compact parts have been introduced quite recently, and they are already available in 20.3 release. In compact parts, all columns and marks for those columns, they are stored in a single file. And this single file still has a columnar structure inside, so the data is properly organized inside, but it's a single file, so it's much faster to write. That's the main benefit. So if you do inserts are much faster, and with these compact parts, it's possible to make much more frequent insert comparing to the previous wide parts. And certainly those compact parts can be later merged with the wide parts. When there is a bunch of small compact parts, they can be merged in order to produce bigger wide parts, and that results in much better efficiency. Just to illustrate this, you can look into data folders for ClickHouse, and for this on-time data set, the original wide format, it has 224 files per part in order to store 109 columns. That's quite a lot. And with a compact format, you only have 8 files. This is a big difference for inserts, and especially for inserts in S3. In our tests, insert to wide column, wide table, if you only want to insert a single row, it could take 70 seconds. We did some optimization, and it's now 10 seconds, but it's still very, very slow. In compact table with compact parts, it's much faster. It's almost as fast as in block storage. Still slower, but not that much. So this is a huge optimization which is already available. Just to highlight, it's a single file, but it's columnar inside. And since it's a single file or a handful of files per partition, it's much easier to do small inserts and much faster, and much easier to use for expensive storages like S3. There are settings to control that, control what parts are considered to be compact. By default, it's turned off. We are working on performance. And last but not least, there is a third version of parts which is coming. Those are called in-memory parts. If anybody of you is using buffer tables, you'll know that buffer tables are great, but not very reliable. If you have to restart the server, you can lose the data in the buffer. With in-memory parts, this is kind of similar to Vertica write optimized store. The data is kept in memory, and then it's get merged to the disk-based merge tree. And we are going to have write-ahead lock that would prevent the data from being lost in restarts. This is a feature that is coming in August, so it's very, very close, and it will make inserts much more easier if you have to insert in ClickHouse fast enough.
Alexander, I hate to interrupt, but I just wanted to say something very briefly. I see a bunch of questions coming in about general roadmap and other things, and keep them coming. We have piles of time, and we'll get to all of them. So thank you very much.
Yeah, sure. Questions, we will answer them, all of them. Next, this is one of my favorite. Those are cluster improvements. So there is a bunch of improvements and optimizations to how ClickHouse works in a cluster. One of them allows to build distributed tables, other distributed tables. That's kind of cool feature, especially if you have several ClickHouse clusters in different regions. So consider that you have 100 servers in one region, 100 servers in another region, and so on and so forth. And this is a giant cluster. And if you have to add a server or remove a server or change a server, you need to change configuration of everything, right? It's not very convenient. We've distributed our distributed. One of use cases is that you can have an entry points for all your regional clusters and have a distributed table on top of those entry points. And those entry points, they in turn resolve in corresponding distributed tables that are local to the regions. And what it gives is to you that if you have some changes in your cluster, you only need to change it in a region. That was original motivation, but certainly it's not the only one. Also quite a cool feature is parallel distributed insert select. Again, if you ever had to copy data in the cluster from one table to another table, from one distributed table to another distributed table, it was kind of slow because you have to use a remote function, for example, and it loads the data and writes the data through distributed table in non-very efficient way. With parallel distributed insert select, when you run this query, ClickHouse automatically understands that for every shard, it needs to do this direct insert select. So it makes this insert select distributed, running on every shard and bypassing this merging and unmerging at a select point. There were a lot of improvements in distributed queries for sharding key. So ClickHouse can skip shards much smarter right now, or it can reuse the information about a sharding key. Again, it helps in performance if you guarantee that sharding key in your distributed table really corresponds to your data. Another cool feature is removing replica without removing replica which has been already lost. For example, right now, if you lose your replica, for example, your server is dead and you need to replace it with something else, it's not very easy because replica has a state in the keeper which is kind of hard to remove. With alter table remove replica, it's easier. Another interesting feature which is coming is database replicated. That makes management of replicated tables much easier than before. The idea is that in database replicated, you define how your replicated tables needs to be created. You define the path in the keeper and the cluster. You define a cluster that will be used in order to create those replicated tables and so on and so forth. And then you only need to create a table, and database will handle the right path in the keeper. It will handle the propagation of your create table to other hosts in the cluster and so on. So you just run one create table statement. You don't need to care about paths. You don't need to care about a lot of things. Database replicated is supposed to take over a lot of these hand operations, handmade operations when you need to create a replicated table. Probably Alexei can explain a bit more later about this upcoming feature. And last but not least, there is a lot of internal modifications in ClickHouse which are currently coming in progress that would allow us to survive zookeeper partitioning. So now, as many of you know, if Zookeeper is down or if Zookeeper is partitioned because of some network problem, you cannot continue to write in ClickHouse. Tables go to read-only mode. Apparently, it's not a design flaw. It's not a serious design limitation, and we can overcome that with some more smart changes in ClickHouse. This is being developed right now. So once it's done, ClickHouse will be a bit less dependent on Zookeeper to be up and running. Certainly it still needs Zookeeper for replication, but if Zookeeper is down for whatever reason, you can continue to insert data, and ClickHouse will continue to merge newly inserted data, but not something which has been already replicated. And once Zookeeper is up, the data will sync up automatically as before. And last slide in this short intro are some, again, my favorite performance optimizations. Actually, the list of performance optimizations that has been done in ClickHouse in the last 3 or 4 months may take several pages, but those are probably the most significant ones. First is parallel select final. If you use replace and merge tree, then you know that select final allows you to get the final state, but it's not always fast. Partially because for some queries, ClickHouse has to do quite a lot of work, and partially because select final was single-threaded. Now it's multi-threaded, and those final queries are going to be much faster. Second, there is a bunch of optimizations going on in ClickHouse that use information about table primary key when you execute group by or order by or distinct queries. So if you know that your data is sorted, you can do much smarter. You don't need to resort it in many cases. And that will result in better performance when possible. There were order by optimization. So ClickHouse order by is probably the fastest order by on the planet, thanks to a lot of specialization for different data types, thanks to use of such algorithms like radix search and similar ones. And those optimizations are still coming, and efficiency in some cases is improving all the time. We also continue to work on Kafka engine, and in 20.5 there is a bunch of changes one more time for performance. Partially we changed some defaults that have been very suboptimal, and also made proper multi-threading model and so on. So performance of Kafka is not a problem anymore. It was originally, but not anymore. And the last but not least is a DBC driver. The new version has been released by probably previous week. And amongst other features, it implemented bulk mode. Bulk mode with bulk buffers. And many clients, and we tested it with Tableau, they understand this bulk mode, and the performance improved 4 or 5 times performance of fetch, which is something that we expect from ClickHouse. I'm done with this intro. So now we are going to answer questions. Robert?
Yeah, and we have some awesome questions here. Here, actually, let me start my video so that I don't look like a strange geometric object. I think this is one both for you and for Alexei. I'm going to take the questions, by the way, in order. If you want to just queue them up, we'll keep working through them until we're done. The first one's from Shashir. Can you talk about the roadmap ahead to address improvements in join queries and data mutability related features, and how ClickHouse database is evolving in comparison to Druid? So I don't know if either you or Alexei wants to take that one.
I think these are 2 different questions here.
Yes.
First about joins, and I was going to talk a bit about joins, but this is very wide topic. So ClickHouse joins has been improved quite a lot in the last 6 or 9 months, both in terms of compatibility and in terms of performance. In particular, there is a mode that allows you to join huge tables that don't fit in memory. So there is a merge join already available. It's not very fast, and there are a lot of plans how to improve join performance in general, but at least a lot of queries that were not possible before, they are now possible in ClickHouse. If you read Percona blog, then keep an eye on that this and next week, because Vadim Tkachenko, who is CTO of Percona, is going to publish a new benchmark of ClickHouse versus MariaDB colon store. And this is a benchmark on specifically on joins performance, because it's based on star schema benchmark. And you will see that ClickHouse, even with pretty limited implementations of joins, comparing to rock solid MariaDB, it outperforms it significantly on most of queries. For a comparison with Druid, I don't know if Alexei can take a lead. For me, it's just nothing to compare. Those are two very different systems. We talked to one of ClickHouse clients earlier today, if you're curious, and they said that they migrated a huge cluster from Druid to ClickHouse. They process right now 1 to 1.5 billion rows per minute, if I remember correctly. Yes, per minute, 1 billion rows per minute. And they load it into 10 shards ClickHouse cluster. Before then, they were using Druid, and after they migrated to ClickHouse, they actually reduced their cost on hardware on 90%, so 10 times.
Hey, Alexei, do you have any thoughts on that, on Druid or join queries that you'd like to throw in here?
Mostly the same about joins. I want to say that we continue to work on joins, and we deliver new improvements in every ClickHouse release. But the task is not limited, and we see that there is more and more that we have to do.
Yeah, and then I think definitely with Druid, we are very interested in, I can just speak for us at Altinity. A lot of people are using Druid. As Alexander says, we do see migrations across. It's definitely, we're definitely looking at it carefully and, trying to understand how ClickHouse can meet the same use cases that Druid does. The architectures, though, are so different that it's sometimes very difficult to make comparisons. So we don't really have super good, we don't really have a point for point, comparison that says, hey, Druid this, ClickHouse that, one getting better, one getting not better, or something like that. That's something that it would be great, actually, if I can put a pitch in for people who have used both Druid and ClickHouse. It'd be really wonderful to have you just queue up a talk. This is the kind of thing where it just makes it's a lot more interesting to do it when you have a real application, as opposed to running, like synthetic data sets. I think that gives more insight.
Yeah, especially if you have experience with both of the systems, it will be very interesting to hear about what is your experiences, how exactly the systems are different in operational complexity, in performance, in hardware efficiency.
Yeah, there is one place where I think Druid does pretty well. I'm not a Druid user myself, but Druid does have baked-in backups, and I think that's been a good feature of the implementation for a long time now. That's an area that we're very interested in. We're about to publish a blog article on ClickHouse backup, which is at this point sort of evolving toward the community standard as for backup, kind of like the moral equivalent of MySQL dump or PG dump. That said, there's a lot of other work going on in backups, and I know Alexei and Ivan, your teams have also been looking at, you have backup utilities that you're also looking at open sourcing. So I think there may be, I think that's an area where I would expect some improvements, particularly over the next 6 to 12 months, which bring ClickHouse to par with Druid capabilities. Let's keep rolling. I hope that answered the question. There was a follow-on. Do you have support for ClickHouse database on GCP Azure as a managed database offering? Well, it's funny you ask about that. We don't. So actually, Alexei, you guys are running ClickHouse in the cloud already, in the Yandex cloud. So that implementation is out there. We will also very likely have something to say on that in the next couple months. So if you're interested, really interested in that topic right now, feel free to give us a call, and we'll talk to you about what we're doing. I have a similar question coming up from Ame. What's the roadmap and timelines for join improvements? I think we've got that sort of covered, and window function support. Anybody want to take that one?
So about window function support, this is the task most likely for next year. For this year, we'll just thinking about what are the best ways of implementation inside ClickHouse, but we did not start the actual development.
So, and anything else on joins, or do you think we've kind of covered that? Ame, if you want to unmute, you should be able to unmute yourself and ask about this if you want to follow on that.
So there was another similar question about joins from MA. Do we have shuffle join in distributed setup? So no, we don't have, but this is the next task that we are going to implement, because currently we have done multiple improvements for joins. Now we support most of the syntax that you will have in typical queries. We also have support for joins in external memory for big tables, but the possible improvements for distributed joins are still to do.
Okay, great. Let's see, next one in the list, another one from May. Dates before 1970 is a big use case for us, and it's been problematic using ClickHouse for those columns. Is date 32 something we can target sooner?
The first step is to finish implementation of date time 64 data type. This data type will allow you to store and manage date and time values before 70s and after 2106. After it will be implemented, by the way, we already have pull request. It is in review stage, so probably it is going to be merged this summer. After this data type will be available, you can also use it to store dates. Just leave the time as 0, and you will be able to store dates. Next, we can think about the date 32 data type, but actually it will be not so necessarily after we will have date time 64.
Okay.
So the answer, most likely this summer, you will be able to store dates and date times before 1970s.
Cool. Okay, here's one from Shashir. This is man. We should have these questions. We should have the answers on flashcards. So if we have to scale out, is there a better way to handle rebalancing of existing data?
This is very popular question. By the way, and the answer is very long. The answer is that there are multiple ways to do rebalancing of your data, and none of them are perfect. But by the way, Alexander, do you want to answer based on your experience?
Yeah, so actually the basic question is that the data will rebalance by itself. So it's for time series applications, so this is usually acceptable because you have new data coming, and if you scale out your cluster, then after a certain amount of time, you will have the data already balanced. Not the old data, certainly, but the new data. If you still need to move the data around, then right now there is a tool which is called ClickHouse Copier, but this is not transactional, and it may require downtime. We actually have a design proposal that we discussed with Alexei earlier this year, how we can make automatic rebalancing in ClickHouse at part level. So at least we can make a solution that would move parts around based on some rules if rebalance is required. And this is probably the simplest that we can do, and we plan to do it, I hope, by the end of year. Going forward, in order to rebalance inside the part and get a more uniform distribution, it's still a question for discussion. We discussed multiple approaches, but we don't have something that we would like to implement. Alexei has a concept of so-called merge tree cloud tables, which kind of serverless. So you, if those are implemented eventually in the future, then you shouldn't care about ClickHouse servers at all, almost, right? You create a table, you specify probably some parameters, how much data do you want to store a single shard, and then this cloud table handles everything automatically. But this is a very, very far future.
Yes, because there are multiple tasks that we have to implement before even thinking of this concept of cloud tables. And the main step before that is to simplify implementation of replicated tables, to limit the usage of Zookeeper, to lower the number of metadata in Zookeeper, to allow inserts in partitioned cluster when some data center is isolated from network, and only after we will implement all these tasks, we will be able to do full-featured cloud tables.
Great. Okay, let's keep going because we've got a bunch of questions here. So here's one from Pauline. ClickHouse supports ingesting from Kafka. Is there any plan to support ingesting from Oz Kinesis?
So do I understand correctly that AWS Kinesis is very similar in interface to Kafka?
I think it's different. Actually, the integration of one technology or another, it depends on two things. First, it depends on certainly on community demand. So if there are many people in community say that they need ClickHouse to be integrated with Kinesis, then we will consider doing that. Another possible approach is that you are doing it by yourself, because ClickHouse is open source, and if you need to integrate ClickHouse with something and you have C++ developers, then you can try doing that. And many ClickHouse features has been implemented like exactly this way. And third approach, if you want us to implement Kinesis support for you, you can go to Altinity, and we're doing such kind of developments. But this is commercial, so it's not very easy task.
And Pauline, if you want to chip in, and I think you should be able to unmute if you want to chip in and qualify what you're doing there, we'd be happy to go into more depth. Okay.
We're currently looking into ingesting data from Kinesis to ClickHouse, but we're in the initial stage. So we'll evaluate the 3 options that Alexander that proposed. So we could think about it further.
Okay.
Thanks for the answer.
Cool, thank you. Yeah, by the way, if anybody else wants to talk and you can't unmute yourself, just raise your hand and I'll allow you to talk. Zoom is kind of cranky about how it manages this. Let's see, next on the questions. All right, here's one. Here's sort of a newer question. I'm new in ClickHouse and didn't use it, but going to consider the usage of ClickHouse to our project in the nearest future. Yay. We like that. So my question is very basic. Is it good to build 50 to 150 columns table for statistical purposes? As I know that ClickHouse is optimized for wide tables, but isn't this too wide for real production use?
Yes, ClickHouse is optimized for wide tables, but if your table is not wide, it will work even better. So it is perfectly fine to have columns with tables with just 50 columns or even 10 columns or even 2 columns. It will work even better because 2 columns is more simple case than 100 columns than thousands of columns.
Right, and certainly our favorite pet data set is the airline on-time data, and that's like 107 columns, something like that. I forget, I haven't counted it lately, but there isn't a problem. There's lots of people doing, like 150 or more columns. We come up with that quite a bit.
And there are many use cases when there are just 2 or 3 columns for time series, for example. Date and time and some tag and value. That's it, right. Just 3 columns. But
oh, sorry.
And probably hundreds of billions or even single trillions of records on each server.
Right.
Yeah, from another side, there are ClickHouse users that have many hundreds of columns or even single-digit thousands. It also works.
Yeah. I think, for example, there was a talk on Uber, how they're building a system for service log analysis. I believe, Alexander, if I'm not mistaken, that one's in the hundreds of columns because they're integrating columns from a pretty wide range of services.
Yeah, and they're also adding columns dynamically, so this number is going to grow.
Yeah. Yeah, so definitely, I wouldn't be afraid of it. There's definitely, that's probably not the biggest, as Alexei says, you can, it works either way. The biggest drivers of performance tend to be about, how much data do you read? So if you have a lot of columns and you don't read them, you're still going to be really fast. And there's certainly, that's something we can dig more deeply into if you have more questions. Let's see, here's a great one, which is a kind of a variation on what we talked about. Is there any automatic integration to get data into ClickHouse from S3?
Mohammed, what do you mean by automatic? So ClickHouse has a number of ways to get data from S3. One way is using S3 function or S3 table or S3 table engine. That allows you to pull data in S3 and even to pull data that is stored in multiple files using a single select insert statement. So if you store a bunch of CSV files, or even the zip CSV files somewhere on S3, you can pull them and load them into ClickHouse with a single SQL command. Another possibility is that I discussed earlier today is using this S3 disk. In this case, the data is stored by itself in S3, but this data is tightly connected to this particular server, so you cannot reuse it. So the way how it's currently implemented, you cannot reuse the data from one ClickHouse server to another very easily without replication. Does it answer your question?
Thank you. The problem that we have is how we have we had Scality as a data source, as a compatible S3 protocol, and what we need to do is to get data from Scality and get it into ClickHouse to perform to be more performant in our queries. So as we know that the data and processing are co-located in ClickHouse, and it's more performant to get data into ClickHouse than to let it in S3 S3 packets. So we try to find some automatic procedure without coding for the moment, if we have some alternative to get data automatically from S3 to ClickHouse. This is the point.
And is your data, what is the format of your data?
Parquet.
It's a Parquet. Yeah. Okay.
Yeah.
That's a good use case that we need to think about that. Right now, there is no automatic way to do that.
Okay.
So you can use S3 table function to import single file or multiple files with wildcard. But what if you have files that appear in S3 every time, and you want just to subscribe to new files and import automatically? In this case, you have to write some script.
Okay.
But it's pretty possible that we'll add some feature to handle this scenario. It's
because Mohammed, is the idea that you have files that are accumulating in a bucket, or the Scality equivalent of an S3 bucket, and you just want some way of having them just get ingested as soon as they appear? Is that the use case?
Yeah, the use case that we have several transactions in, that came from HDFS Spark processing, and after doing all the ETL processing, big data processing, we output the data in S3, and then for the analytics part, we want to get all this data from Scality to ClickHouse to perform to offer a self-service for BI teams.
By the way, another approach to this problem is to use Kafka. I'm pretty sure that Kafka has integration with S3 in a way that you want to, and we have integration with Kafka.
Yeah. Yeah, I was going to suggest that as well. That's a really good idea. Good. Okay. Great. I hope that helped. Let's see.
Thank you.
Here's a good one. Sasha, I don't know if you know this. Does the ODBC JDBC driver support inserting structs in arrays?
I'm pretty sure that JDBC driver does support arrays. I'm not sure about ODBC. Joshua, do you remember?
I don't remember exactly, but most likely not.
Yeah, so ODBC not, JDBC yes.
Yeah, definitely. You know, we do the maintenance for ODBC, so that's actually one where if you had a really burning need for it, we could probably put that in. JDBC. Who's maintaining JDBC right now? I think that one's got a little bit of. It needs some love, I think.
Yeah, it's need a maintainer. So right now, it's maintained not very well.
Okay, yeah, that's one. I've been programming in Java since I was actually for about 25 years. So I'm pretty interested in the JDBC support. Maybe we'll pick that up. So if you run into problems, definitely feel free to ping us either on the Slack channel or on Telegram, and that's definitely something the community can help you look into. Let's see. Okay, inserting Parquet file data with lists and structs is a big pain point for us due to gaps in Arrow, and we end up using JSON. What recommendations would the ClickHouse team have? Is it possible to fix the issues in Arrow? And by issues, I'm just going to assume that this is an incomplete. Is this an issue with Arrow not fully supporting Parquet, or is it our implementation not fully supporting it? Maybe somebody can clarify that.
It's just a lack of support of arrays. So for some formats, arrays can be read but not output. For other formats, vice versa. But it's not a fundamental issue. It just needs to be implemented.
Got it. And it's not something like we have to dial up Wes McKinney and get him to support it in Arrow?
No.
Are they, I assume Arrow supports this.
Yeah.
Okay. So yeah, it sounds like it's possible to fix. If you have a really burning issue and you need it for a commercial project, that's the kind of stuff we do. In fact, we love projects like that because they're fairly focused and we can deliver them quickly. Is there any, as far as community, Alexei, do you know where that would stand on? Is there anybody in the community who's working on this stuff right now?
No. The task is free to take.
So if anybody on this call wants to earn their committer badge, this is an opportunity to fix this one. All right. Let's see. I think we kind of covered this from Amit Sharma. What about the cloud merge tree table implementation? The blog has been published for, and this was the cloud merge tree. And I think you talked about that, yeah. Alexei, and also some of the steps that are necessary to get there.
Yeah. So the answer is that it is not implemented at this moment of time. But we still have some expectations and all that.
Yeah, and I think that I know from our side at Altinity, we're also super interested in this problem because I think right now, one of the things that's kind of striking about using ClickHouse is you have to know where all the hosts are to use ClickHouse fully. And I think the place that many of us would like to get to is there's actually just one API endpoint that you go to, and from that endpoint you'll get to the right shard or the shard equivalent. You'll get to the right replica for whatever it is you're doing. And I think that the cloud tables also, that for me, Alexei, is kind of the endpoint of that development, that the data is just there and your queries will find it. Your inserts will actually put it in the right place without having to go to specific hosts. Is that how you view the cloud tables?
The main idea, the main motivation is, suppose you have some cluster of whatever number of data nodes and you want just to insert some data, but you don't know in advance how big the table will be. Do you want this table to shard across all servers or across just some subset of servers? You want to start inserting this data onto cluster to balance this data automatically.
Right. So it's sort of, and I think what a lot of us have in our heads is that, and a lot of users that we talk to are thinking Cassandra, and with consistent hashing, and ClickHouse can't quite do what Cassandra does. And I guess the other issue, and Amit, if anybody on this call has interest in this problem, we would definitely love to talk, because I think that this cloud tables concept is also closely tied to multi-tenancy and being able to support, like Alexei, when you talked about groups server, like a subgroup of servers within the cloud tables, that might be a group of tenants, and then another group of tenants, another group of tenants, being able to manage that efficiently and have the data land in the right place. That's definitely something we're in conversation with people about right now to try and figure out how to do that. So if folks have thoughts on that, please do chime in, join Slack, join Telegram, and let us know what you think, or call us directly. All right. Here's a good one. Here's from Nitin. When we're in production, the analytics team have the requirement to have raw data extracted from ClickHouse. How is ClickHouse performance when it comes to extracting raw data, all columns, for a given time range, given that each column data is stored in different files? Anybody want to take that?
ClickHouse will just stream the data to the client as quick as possible, and there is nothing wrong in this type of queries. It only matters how fast you can read this stream of data. So, would you like to add on this question?
Yeah, Sasha, do you have any thoughts on that one?
Yeah, I think in general, ClickHouse will perform faster than loading the data from not ClickHouse, primarily because of compression. So since the data is compressed, it consumes less disk space, and it's faster to read because we see the storage is typically a bottleneck, especially if you are loading a lot of data and importing or exporting it somewhere. What is bad in ClickHouse if you want to load just a handful of rows from the byte table? So if you select like 100 rows, limit 10 or limit 100 from a table, it's not efficient. ClickHouse will introduce a lot of overhead of reading extra data in this case. But if you're loading a bunch of data, full day of data, or a full partition somewhere, and export it to CSV files or whatever, that's sufficient.
So maybe I have to clarify. So there is some statement in the documentation that don't do select star. It is inefficient. So the question is, what if I will do select star from my table where some range just to export raw data? And the answer is that even if you will do select star queries, there is nothing specifically inefficient in ClickHouse. We can only say that select star is less efficient than select a few columns. But if ClickHouse will get select star query, it will still try to read these columns as quick as possible, and I can say that it will do it in the most efficient way as it is possible.
Yeah, one of the things that jumps out, because I've actually had to deal with this problem before, a little bit on ClickHouse, but also in other systems. I think the thing that I would be looking for on this is, if you have, like, let's say you're going to like a 64-core ClickHouse machine on NVMe SSD, and you run a select star, or choose any query you want. If you just run it on one network connection, that's going to be your bottleneck. So, because ClickHouse is going to be able to read this stuff blindingly fast, and you get full parallelization, and then it gets reduced down to a single TCP/IP connection. So one of the things that I would probably look at, and I've actually implemented this in Python for ClickHouse a while back, is to try and get some sort of parallel download. If you know that you're dumping a bunch of raw data, one of the things you can do is go to system.parts, and that will tell you what the parts are that are in the table, and then you can construct it, sort of read down system.parts, construct queries that will read the individual, that will just scan particular parts, and then your application runs those queries in parallel. There's some, if you want to contact me afterwards, there's some Python I can point you to that does pretty much exactly this, or at least shows you the direction. That's definitely something I would consider for that. I hope that's helpful. So hey, here's an interesting one for you, Sasha. While ClickHouse is introducing write-optimized storage, the in-memory parts with write-ahead log, Vertica is deprecating write-only storage. And so what's your view on this? Because I know you like Vertica.
Hi, hi, DJ. That's a good question. I briefly read the Vertica article, and the reasons they have write-optimized storage and they don't have. And I'm not 100% sure that they are doing the right thing here. From one side. From another side, implementation of ClickHouse memory parts is different from Vertica was. In particular, it's durable, thanks to write-ahead log. This is something that Vertica didn't have. Probably Alexei can comment more on internals of this implementation, but it really one of the things that ClickHouse community is looking for, because it's better than buffer tables that we're having right now. Buffer tables are more like WAS, not exactly, but from insert perspective.
Yes, I can also elaborate on this. So, what is Vertica trying to deprecate is much similar to buffer tables than to in-memory data parts that we are going to introduce. And by the way, we also would like to deprecate buffer tables when insertion into merge tree tables will be as efficient and even more efficient than what you have with buffer tables. And about what Vertica is going to implement to deprecate write-optimized storage. What they are going to implement is what is very similar to compact data format. So after we have compact data format, the performance of small inserts is improved from 10 to a few hundred of times. So you cannot just compare write-optimized storage in Vertica with something that looks similar in ClickHouse at the first glance, because they are actually very different.
Yeah, and I think it's they are started to steal our ideas, right? So compact parts appeared first in ClickHouse and then in Vertica.
Maybe.
To be clear, they call it ROS bundling. They had it, I think, for a while also.
Yeah, when I read these articles, I see all similar concepts with different names.
Oh, thank you very much. It's more or less clear, but I have a small follow-up. So there is a case we have like for like hybrid transactional analytical processing with new data being inserted, and new data has to be like sometimes edited with some data quality checks or some delta calculated between rows dynamically. Similar things. Is there any plan, like long-term plan, to introduce some row store parts for like most recent data that can be moved with TTL policy or something else, or with some limit in the aging, so that to have them like this in-memory parts in a column in a row store format with support of direct updates and insert and deletes and DMLs?
Actually, it's a big area of development to implement point updates and deletes in some efficient manner. And there are multiple approaches to this task that we are currently considering. But this is in a roadmap not for this year, but for next year.
Okay, thank you.
Great. Here's an interesting one. It sounds like somebody's been using BigQuery because it's Jan Prach. I don't know if, I hope I'm not butchering your name. Any plans for arbitrarily deep nested structures?
Yes, the answer is yes. There is a plan to implement deeply nested structures, and this is not only from new feature standpoint, but also from internal implementation in code base. It requires some refactoring, and I hope that it will be some first step to better support of semi-structured data.
Jan, I allowed you to talk. I just wonder if you want to follow up. Are you using BigQuery by any chance, or some other database that supports this?
Yeah, I was actually working at Google, so there was a lot more things I was using, but that was a good realization of the value of the nested data structures, actually.
Yeah.
And so we have like Spark and whatnot, right? And we can, and well, actually, it also doesn't have perfect support for nested stuff, but it does have it, and it's actually very useful. And people have naturally like JSON and whatnot, so it makes sense to have that reflection. So actually, like having just one level nested in ClickHouse is actually kind of limiting in how we model the data.
Yeah, well, you can pull data out of, like if you store stuff in JSON, you can use the JSON extract functions to pull data out, but it's pretty painful. We had a project earlier this year where we were working on that, and it was, yeah, let's put it this way, it was not as easy as we would have liked. So, Alexei, is there some notion, can you describe a little bit more what you're thinking there? Is this something where you'll have the data structure explicitly, natively represented in ClickHouse? Is that how this will evolve? Because I'd love to see that too.
The first step is to have some fixed data structure, just to not limit it to one level of nesting. But it is just the first step.
So I don't know ClickHouse that well, but I would expect that arbitrary level nesting should be relatively easy to add if there's no support for the repeated arrays. I think repeated would make it harder. Because if you think about it, you could represent the arbitrary nesting as just name and mangling, basically.
Actually, we have support for arbitrary deeply nested arrays. You can store 2-dimensional, 3-dimensional, whatever dimensional arrays in your tables. You can also organize them in tuples, and you can have tuple of arrays, whatever. What you cannot have is just to specify nested data type of another nested data type. But you can have multiple dimensional arrays inside nested data type.
Interesting. Thank you.
You're welcome. Okay, great. All right, so here's next one, Nitin. And by the way, there's a couple questions in chat, which two from GNU. We'll get over to those in a minute. As we want to onboard different teams onto one ClickHouse cluster, what is the best way to organize data of these different teams in a single cluster? For example, like using namespace. Any light on how Altinity or Yandex organizes data of different clients on one cluster? Either one of you want to take that?
Alexander?
Yeah, that's a good topic. So actually, it's very much depends on the company and a number of teams, or sometimes number of tenants, if you wish. So right now, ClickHouse can. So if there's a teams inside your company and they need to see the different data, then you can use row level security, for example. Row level security allow you to apply filters dynamically based on the logged user. and it's pretty good. But it doesn't always work for security regulations, for example. So if you have multiple tenants, you probably don't want the data to be shared inside the same table with those tenants. In this case, you can go to different approach, having separate databases or separate tables or separate partitions per tenant, thus having some data isolation, not on the server level, but at least at the storage level. So you could probably store it differently and possibly to encrypt it in the future with some encryption methods. For huge companies that have hundreds of thousands of tenants, and Yandex is a good example, they have to do it on application side, because you can't have 100,000 users in ClickHouse. You have to use a single user, or probably a number of users.
We do have
100,000 users?
Thousands of users, yes, in the ClickHouse. By the way, they are configured with old approach with XML configuration, but now we have role-based access control and the possibility to create users with SQL queries.
What is the size of your XML file?
I can check, but I think it's just maybe 100 kilobytes, but not so big.
Okay, anyways, it gets complicated if you have too many tenants and too many teams. One of the projects Alexei can comment better is to implement proper resource isolation, resource pools. Probably this is coming next quarter, right?
But first I want to say that these users in our clusters are not different tenants. They do queries on the same data set, but with some limitations with row level security. So they see different subsets of this data. They are just different analysts who analyze internet traffic. And about resource sharing. First, if you have multiple tenants in a single cluster, you have to specify some limits on resource usage and quotas. And that is what we already have in ClickHouse. We have multiple settings to limit resource usage per single query or per user. For example, the maximum execution time of query, or the maximum amount of data that a single query can read, or the maximum amount of concurrent queries that a single user can execute. And you also may want to specify some quotas, and quotas is a limit on resource usage for some range of time. For example, to limit the number of queries that specific user can execute per 1 hour. If the quota is exceeded, the user will receive exception and will have to wait for the next time period to execute next queries. But what we are going to implement to improve this further is resource isolation. Resource isolation and resource sharing between users. And this feature is currently in development. So you will be able to configure the share of CPU and share of memory usage and share of network bandwidth that some user or some pool of users will be able to use. This feature is in active development right now, and we have some first results. And the first results are that this is definitely going to work. And I cannot say more.
Great. Okay. There's a bunch of variations on this problem. I think there's a whole digression into bi-level sharding that we could do here, but had this meeting set for 90 minutes. I want to keep going so that we'll cover the questions, because there's a bunch of, there's still several interesting questions here. There's one I'm going to just jump into that just popped up from Courage. Any plans for access control like integration with LDAP? I think we could say emphatically yes.
Yes. Yes.
We have, yeah, we've been testing the daylights out of it. There's a test user called Gandalf the Grey who's been hard at work for, I think, Alexander, like a couple months at this point, beating up LDAP.
Yeah, so LDAP authentication is going to be merged today or probably tomorrow. It's already a feature that has been completed and well tested. And next, we're going to work on mapping of LDAP users to ClickHouse. So right now you have to have a user in ClickHouse, but you can authenticate it in LDAP. Next step is to keep everything in LDAP. So you don't need to configure on ClickHouse site. You only configure that you use LDAP server and probably some mapping of roles from LDAP to ClickHouse if needed. So this is going to happen soon in the next couple of months.
Yeah, that one's coming. Here's another one. Does ClickHouse do projection pushdown into subqueries? For example, select a comma few comma fields from select star from table with lots of columns. Is ClickHouse smart enough to do that?
Yeah.
Okay, great.
But recently, not always.
For this type of query, always. And it was available at least even before ClickHouse came open source.
Okay, so that's a big yes in capital letters. Oh, here's a great one from Newton, who's not on the call, but according to the official ClickHouse documentation, a table with aggregating merge tree will have one row for the same primary key. But in production, we've seen that there are more than one row for the same primary key, and many times we have to use optimized table final to collapse the rows. Some more. Do you want to comment on this, Alexei? Because this is, I think, goes to kind of the natural, the way ClickHouse manages data, and like why you would get.
Yeah. Either documentation is wrong,
yeah,
or you just read documentation incorrectly, because it should be clearly stated that data is aggregated in background during background merges, and data is always kept in some not completely aggregated form, so you will have probably more than one record for every key. And this is how it is supposed to work. This is normal. And usually when you query aggregate and merge tree table, you also do group by to aggregate data completely on select.
I can also add that for argmax, you don't need to use aggregate function, but you can use a simple aggregate function, which is much easier and faster.
And the other thing about this in terms of storage organization, the fact that it's not fully aggregated is what enables us to distribute data across a bunch of hosts. So I think with ClickHouse, you should never assume that things are fully merged or fully aggregated, because the data is this is designed to support distributing the data across many hosts, and you often have pieces of the aggregate, if you will, in different locations, and then ClickHouse combines them. So it's by design that it's not fully aggregated.
Yeah. So when you use aggregate and merge tree, ClickHouse does most of aggregation in background, but you still have to write aggregation in your select queries.
Yeah. Yeah, great question. I think it goes to very, very basic, sort of design of data. And so thank you for asking that. Let's see. Got a last question in the list of questions. It is, how is multi-tenant isolation suggestion in ClickHouse? I think we kind of covered that. This is to ensure one tenant does not get another one's data. And Alexander mentioned a number of options: put it in different databases, put it in different tables. Alexi talked about resource management, which will keep the neighbors from bugging each other. I think there's always a trade-off between, between separating data completely and achieving high performance. Because if you have a very large number of little files, it's going to fragment your memory. In a variety of ways. It also means that there's a lot of files you have to open up and look at to do queries. So I think there's definitely a trade-off here. One other really interesting issue that we are beginning to look at is how to do encryption, and particularly in multi-tenant data sets where you might have tables, data for tenants, multiple tenants in the same table. There's a first step on this coming in the next few weeks, which is implementation of AES encrypt and decrypt functions. They're on the model of MySQL. But we see this as kind of like putting our toe in the water of this deeper problem about how to encrypt data across multiple tenants in the same table with things like rotating keys. Not something that's going to get done this year, but we're definitely pointed in that direction, and this is something where I hope ClickHouse will get to.
And maybe the question is actually more simple. Suppose if different tenants already have their data in different tables, and then it will be enough just to use access control features in ClickHouse. I should highlight that in recent versions, we have implemented full support for access management with role-based access control and SQL interface to manage roles restrictions.
Yeah, so that's another stuff, one that's getting pounded on right now. Hey, here's one. I'm going to go to the questions in the chat. Got one last one in the Q&A box. Very basic question, but really wanted to ask. I want to contribute to the ClickHouse code base, but I'm not sure how to start. Is there a list of easy bugs or features that can help me get started?
Yes, there is a list of issues that are labeled as easy task. Just go look at this list, and I hope you will find some interesting for you. And your efforts will be very appreciated, and we will help to answer your questions and to help with polishing the code and merging your features.
Great. And then when we can finally have in-person meetups again, we will sing your praises and give you t-shirts and badges and things like that. We love it when people contribute. I've got a couple of, let's see, a quick question. Apache Arrow also needs some love since it doesn't support reading or writing array or struct. I think that's, thank you for that qualification. That's from GNU. That's something I would like to look into. If you are interested in that, feel free to contact me offline. Or if you can qualify this on the call, I think you're able to talk. Let me see if I've got you enabled. Weird. No, he may have dropped off. And then finally, is there any plan for better support for the with statement? I think that was sort of covered under CTEs, but as
there is a few. There are a few tasks on better support of with statement. The first task is to allow to specify subqueries inside with. And the second is allow to use definitions in with statement inside subqueries. Two different tasks on top of with and subqueries. And these tasks are not hard to implement, but if you will not think about full support for CTE, especially recursive CTE, it is a little bit more hard to do, so it will be next after the first steps.
Great. Okay, I think we're at the end of, here's a question. How do we pick the version to use? Alternity has a different version versus official documentation. Sasha, actually, since those are like the Alternity stable releases are kind of your baby, you want to comment on that?
Yes, so it's not different, it's the same. The only difference is what we consider stable. So ClickHouse stable releases in ClickHouse repository are those that pass all tests and some internal QA or development team. And if you look in ClickHouse naming, release naming convention, actually release number consists of 4 numbers. First is a year. Now we have 20 releases. Second is a major release. So we have 20.5, which is the latest to the moment. And third is a bug fix release. So if you see that the release number is 20.5.2, this is very early release in 20.5. And usually those releases have some problems, regressions, and different sort of issues. Unfortunately, right? They're marked as stable because they're stable for trying, for using in development environment. They don't crash, right? So they're stable enough, so they're marked as stable. From Altinity side, we have our own certification process. Then we try to certify releases that are safe to use in production. So the current Altinity stable release is 20.3.12, and there was a 13 release today that we need to look into closer. And we're sure that using this release in production is safe enough. You don't have unexpected crashes, and we know all kind of issues that you can face. So that's it. It's the same release, just a different certification process.
Okay. So the same package, the same binary,
yep.
Just different process of picking the release to recommend. And also I can say that if we're aware of some regressions or some bugs in corner cases, we're just going to fix them before naming some release as stable. This is just that we must do. If we have some stable release, probably there are some regressions that just did not show in our production, that did not show in production of multiple different teams in Yandex, but they still has to be discovered. And sometimes you may want to just wait for some time, so some release will be battle tested in more production environments in different companies, just not to be the first.
Yeah, but we appreciate those the ones that go first, because the feedback from community is very, very, very important.
Yeah. So one of the penguins has to be the first one off the iceberg. So yeah, we're very grateful that it's not. No, I wouldn't say we test this stuff. Obviously, everybody on this, we're testing all this stuff, well before most people. There's one final question, and then I want to close it. For folks on the call, you probably don't know this, but or you may not be aware, but it's 20 to midnight, or getting close to 1/4 to midnight for Alexei and Alexander. From Jan Prach, any thought on supporting some common SQL dialect like Zeta SQL or Apache Calcite? Call that the last question.
It's not so easy to answer, because if we will just take Zeta SQL or Apache Calcite, we will lose some benefits of ClickHouse dialect, like support to specify and use aliases in every place in SQL. It is just not conforming to SQL standard, but it is very convenient. Or we will lose our syntax for higher order functions for arrays and arrays altogether. We will lose some query clauses like final. So we cannot just take Zeta SQL as is. But what if we will take Zeta SQL as some alternative dialect to support for ClickHouse? If we will do that, we will have more area of support. We will have two different SQL dialects, and we will have to support both of them. It's also not very convenient for maintenance, standpoint. But what we are going to do is to rewrite our own SQL parser to make it more suitable for analysis and extensions, to make it more compatible with standard SQL. And SQL compatibility is one of our main tasks for this year, and not only for this year.
Great. I think Alexei and Alexander, we should probably call it a night or a day, at least for us Californians. I want to thank everybody. I hope that, particularly Alexei and Alexander, for staying up late and joining us and contributing these wonderful answers to questions. I hope people found this productive. Feel free to set something in the chat. This is definitely something we plan to repeat at intervals. In the meantime, we have three ideas for upcoming meetups. I just want to give you a sense of what they are. If you think you might want to speak, please contact us. The first is we'd like to do a meetup in the not too distant future to talk about ML, or sort of machine learning and ClickHouse. That's something we're thinking about, and we have a couple of candidates potentially to do talks. Second interesting topic is ClickHouse visualization. So ranging from Grafana to Looker to other tools that are up and coming and give you the ability to view and manipulate data easily in ClickHouse. And then a final area that which will be in an upcoming meetup, one of the largest ClickHouse installations in the Bay Area. We had a conversation with them today. They've been working on converting two use cases to ClickHouse from Druid and Elastic, and have some really interesting experiences to share. Alexander mentioned them. They're doing between 1 and 1.5 billion events per minute, which is about 25 million a second. So this is even bigger than some of the numbers we've gotten out of Cloudflare. That's another one that's on coming up, hopefully in a meetup presentation in the not too distant future. So please do, if I know you all are doing interesting things with ClickHouse, please do consider presenting. We're really friendly, and we just want people to share their experiences. You can contact me directly if you're interested in presenting, and or reach out to us at info@altinity.com. Just get in contact. We'd love to have you come present and tell us what you're doing with ClickHouse. So with that, Alexei and Alexander, thank you very much. Thank you also, Ivan Blinkoff. I think we'll call it a day.
Thank you, Robert, very much for hosting that. You're doing great.
Yeah, so we'll have to have you out to the Bay again soon. Talk to you soon. Bye, everybody.
Thank you.